All right, welcome, folks. I see we have some people entering the room, and so as we are having folks join, appreciate you taking the time to join us here today for our Ask Mayfield Anything. Today, we're going to be talking about microgrids, overcoming common microgrid development hurdles, and should be an interesting hour. I have a couple great guests. We'll do some introductions here in a moment. And so, as you're filing in, one of the things we like to talk about, and well, one of the things that we try and do with this entire AMA series is have it be interactive. And so there is a Q&A function, part of the Zoom feature. And if you can put your questions in the Q&A spot, not the chat, really helps us manage those and make sure that we are answering those, seeing those properly, and being able to get to those. So really appreciate you doing that. And as they come in, feel free. I will try and integrate those into the conversation in real time as it is appropriate. So please feel free to do that. And then you do see that there's a poll there that we like to just kind of get from people an understanding of, what it is you're looking for, what's out of this specific topic. And then, if there's ever anything future-wise, love to hear from people and be able to talk about that and be able to think about future topics. So feel free to let us know on that as well. So for those of you who may not know me, my name is Ryan Mayfield, founder of Mayfield Renewables. And this AMA series is one of the fun things that I get to do with bringing in really smart people, being able to have great conversations, understand some pretty big topics within the industry, and microgrids being a really big one for us. This is something that we at Mayfield, we've really leaned into. I know both of our guests have really leaned into it as well. And so really excited to have the conversation with them and kind of talk about that. At Mayfield Renewables, who we are, so we are a consulting engineering firm, and we do a lot of project engineering and consulting for our clients. We also do a lot of education and training. And so I've been doing teaching, training for many, many years now. And it's one of my passions. It's one of the things I love to do. This AMA series, along with like the dispatches series that we have code corners we put out. So we're putting a lot of content out there, and it's just kind of a part of who we are as a company. Today's webinar, we're going to be talking about, again, the microgrids. This is a kind of a look into our education summit. So both Eric and Markus are going to be joining us at our education summit, which is in October in Seattle. I'll show you some information about that towards the end of the deck, but this is going to use kind of a sneak peek into one of the things that we're talking about on this very topic when we're in person in Seattle. So we'd love to see people join us there as well. We'll get you that information towards the end of the webinar as well. All right. Quick introductions. I want to take a moment, let our guests introduce themselves and kind of where they're at in the industry, where they started, kind of how they got going, and then kind of where you're at right now with microgrids, especially kind of where you sit and what your companies are focused on. So Eric Bastoul, we'll start with you first, founder and principal at Topsis. So Eric, we've known each other a long time. So yeah, I'd love to have you introduce yourself and to the audience.
Yeah, thanks, Ryan, and yeah, thanks for having us here. I'm excited to be here and chat with you guys. So started my career kind of doing solar and battery on the EPC side, doing engineering, kind of just in the weeds, commercial, and then utility scale project development, and then engineering. Got really interested in microgrids at some point, and found myself working at a microgrid company based out of Barcelona, Spain, doing work in Africa, South America, and the Caribbean. Basically doing early stage development and then later stage engineering and actually like construction, kind of like commissioning and supervision. Recently moved back to the States, started the firm Topsis Energy, where we primarily focus on solar batteries and a lot of microgrid stuff. Electrical engineer background, I'm a PE, and I'm happy to be here and chat with you guys today and talk about some microgrid stuff.
Awesome. Thanks for joining. And then Markus Virta, I asked you before. Hopefully I can't quite get the accent right on that, so I apologize on that. But Markus, wonderful to have you right up the road in Bellingham from where I sit. And so co-founder, managing partner at Cascadia Renewables. So tell us a little bit about your history and kind of what Cascadia is up to.
Yeah, thank you, Ryan. I got started in the solar industry in 2010, working for a little residential commercial installer in Bellingham, turning wrenches as an apprentice installer, worked my way around that company and still do a lot of work with them. But in 2022, jumped off and formed Cascadia Renewables, because we saw a need after the Inflation Reduction Act passed to support local governments, tribes, and nonprofits owning and operating solar storage and microgrid projects in the region. So we've been really focused on microgrid development for public good and specifically resilience in the Pacific Northwest. So we didn't do that for a little while, and then we also formed a company called Topsis Energy last year that is installing projects as well. On the BESS and microgrid side. So been swimming in this water for a little bit. I actually first installed a small microgrid for my previous employer in 2012 it's a small project in Whidbey Island that was a shelter for folks on the island in emergencies. It's kind of a mass care facility, but it was a little tiny church that had an outback radiant system and AGM batteries way back then.
Nice. Yeah, I think that yeah, going back to the early days, doing a lot of battery-based systems myself, and so always interesting to see kind of how we've come along. So thanks for joining. And yeah, so it's just also full disclosure, Mayfield Renewables, we work with both Eric and Markus separately, and so it's great to have you guys here. I know that we've had a lot of communications over project specific things, but you guys taking the time to kind of participate in this and work with us is I really appreciate you guys doing that. All right, so let's get into the topic here, overcoming common microgrid development hurdles. We have a handful of slides that we're going to go through, and this first one I'll just pull up right now, and ultimately we're going to have this page filled. And we worked on this graphic. This was something that we did in concert with Cascadia with Markus, and they have kind of a similar thing, and we had something similar, so we kind of took the two and definitely molded them together, and Eric had some great input on this as well. So trying to break this down into multiple stages and really want to get your guys' input on this in terms of, what's kind of these key parts of this stage. And then as you'll all see in the audience, I mean, there is definitely some, throughput on these, and then ultimately it's kind of circular in a lot of senses because there's always this kind of feedback loop that we need to get into. So on the planning and feasibility, Markus, maybe I'll start with you on this one. Just kind of, when you think about planning and feasibility, what are the big things that you're thinking of and kind of first steps for you when you're looking at these a microgrid development project?
Yeah, so from a resilience standpoint, we always start with the local comprehensive emergency management plan to try to understand how the community that we're serving is engaging in an emergency and what they've written down in their plan as their needs are. And we take that kind of lens and go to the community to try to understand both, how are they utilizing that plan and how does that manifest in reality? Instead of, trying to develop like a resilience hub at a fire station or a school in a community every time, we found it's more effective to ask the community where they're going and where they're spending time and to develop the resilience hub where they're already at. So we found the best way to ensure solid kind of community engagement is to start by listening to folks and developing the projects that they want and that are in their neck of the woods already. And I think that helps to establish the kind of tone of the engagement with the community as one of service. And then that kind of social aspect of the project then can bleed through as a through line through the technical and economic analyses that we would then do in the development process.
Perfect. Yeah. And so, Eric, I guess I'd love to hear your bit on this as well. And so I think on my lens, a lot of this around, defining project goals as far as an engineering firm and an engineering team is like, that's always a big one. I think what you were saying, Markus, it's really important to where are we even starting? Where is this community even, what's that baseline? But so trying to not jump the gun too much, I guess. But Eric, I guess, yeah, open it up to you in terms of, defining those project goals and other parts of the planning phase.
Yeah, definitely. The project goal is this. I would really underline that part as kind of like point number one is like yeah, open to listening to whoever the client is, whoever the community is. I think Markus, you do a lot of work directly with communities. I do as well. But I have done a lot of my work like directly with like a specific like building owner. And when that's the case, then the conversation, is very similar, but it's maybe like with an individual or with a firm, and kind of sitting down and be like, all right, what is our goal for this project, right? Are we trying to be offline to be resilient for 24 hours or 48 hours? Are we just trying to save money? Are we trying to, I guess another option would be like, we can't connect to the utility grid to new construction. We can't connect to the grid because the timeline is 3 years. So our goal is just to get the site up and running in the fastest time possible, right? And so just kind of defining those things and getting on the same page is, kind of the first step that we would take in any of these. And then of course, the site assessment, kind of doing like, if it's an existing facility or existing community, doing a load assessment. And really kind of in this stage is like, it's the feasibility stage. It's like, can this project continue forward? And what's the sizing that we want to move forward? Like, are we going to do batteries with solar? Are we going to have a generator? Where do we connect? And then trying to define project costs and cash flow to be like, does this project pencil? And how does it go forward? And does it pencil from an economic perspective, or can it be funded from, maybe a grant perspective? And I don't know, Markus, maybe you have some more insights on that one. I think a lot of your projects are grant funded, right?
Yeah, they are, and it's the wind blows in different directions, so it's important to have kind of a diverse strategy for financial kind of deployment of these assets, and also recognizing that the stakeholders of a project, including the site owner, are going to have differing levels of kind of financial sophistication. So being able to package what is a really technical thing, a microgrid, and especially the kind of financialization of them into layman's terms has been, really imperative for our success at both finding and seeking out grant funding, but also looking at kind of financial optimization models that allow us to utilize more kind of standard financial pathways for these projects.
Yeah, I'm sorry, go ahead.
Nope, go ahead.
Oh, I was going to say that prompts me is like in this stage, I feel like a lot of the things that we see going back and forth with clients or communities is a stage of kind of like education of what is the possible. Like, this is what we currently have. This is what we're trying to get to. And then having kind of a developer and engineering firm kind of come in there to fill that gap, to be like, this is what we can do to accomplish the goals that we're trying to set out for. Often there are limitations on just like how the site is configured or like what the available land is. And you're just like, we can do this or we can't do this. And there's a lot of cool technology out there. So most cases it is possible. But sometimes it's not.
I would just say, I think like one of the reasons we love working with Mayfield is that kind of culture of education is really strong at Mayfield, and we feel that is the best pathway forward, developing these projects with communities. Is listening to the latest podcast with Jigger Shaw and the GRU, and he was just talking about embedding ourselves in communities and making sure we're there beyond just a single project. And I think that's really bang on. Our industry has been really focused on turning dollars into kilowatt hours. And sometimes we miss the forest for the trees, and recognizing that there is a real value in the social aspect of these projects, and articulating that to the community with the community is how we get that grassroots strengthened and lasting kind of policy change in the industry as well.
Couple of things I want to hit, and then I want to make sure that we move on. So we have a number of points to get through, but a couple of things there. And one of them is around, you talked about this earlier, Marcus, just the community engagement and understanding where to put these systems. I saw a question kind of come up is like, well, the police station's obvious, the senior center's obvious. So maybe that seems kind of obvious to us as developers and engineers, like, oh, of course you should put it at that location. But engaging with the community because if the community center is on the other side of the river and the expectation why we're putting this in is because of an earthquake and we don't know if that bridge is going to be there, then a resilience hub on the other side of the river from where the population isn't going to help. And so listening to the community and understanding where they're actually going to be and those kinds of things. So I think that's a big part of it. And then feasibility is always a big one for us, and getting in there, understanding what technically, economically, all those things, what these can and can't do. And so Robert has a great question that he put in there about asking about finance hurdles. So I don't know if you guys want to, if that's a good one to put at this moment, planning around, the finance hurdles, what are those outside of grant-led projects? So Eric, I don't know if that's, Marcus, I know you're not doing just grant-led projects. So you'd love to hear your guys' take on that.
Yeah, Robert, we'll get to one of the examples that we have later is specifically a project that is like economically driven, but kind of just address it a little bit right here that it is a challenge is to predict a cash flow for a project that is reliable and that is bankable for the next 10, 20 years, right? Something that the industry is generally kind of going towards is like a couple different models for providing financing for the microgrid. So like one of them is microgrid as a service or energy as a service, where the microgrid is owned by the developer. So they own the solar panels, own the batteries, maybe the generators as well, and they own and operate. And they're essentially, you can kind of think of them as just like a small little utility on site that owns and operates and is responsible for the maintenance. And then they sell the electricity back to the client or whoever is on site. That's an option. We also see revenue share options where the developer will come in and say like, hey, I will guarantee you this amount of savings for the microgrid or from the utility rate. And anything above that savings or any rate below that, we split the difference on that. So there are a couple different models and creative ways to go about it. But I would say, one of the largest challenges is this kind of like shifting policy environment or shifting rates of electricity where, we think we know what our revenue is going to be for the next year, 2 years, 3 years. But it's hard to predict what that's going to look like in year 5 or in year 10. Generally, we can make assumptions about the cost of electricity and what that's going to escalate to. But yeah, it's something to work through. It's a challenge.
Great. Okay. I'm going to kind of keep us moving along. We have a few more columns here, as you might be able to tell from this slide with the white space there. So kind of just want to get through, not necessarily the entirety of everything, but just kind of these big points. So procurement and contracting, you kind of talk about, or we look at, and we see that, what our goal is there, and then kind of what we're getting. So that securing that funding, kind of what you were just talking about there, Eric. So I guess on the procurement and contracting, Marcus, this is a big, you're involved in this. As Sulis is doing that day in and day out. And, I guess if you had to pick one of these like biggest hurdles or something here out of this side of it, what would your number one thing to kind of on the procurement and contracting side?
Getting the level of engineering and detail right in the RFP is critical. I was the president of the Washington Solar Energy Industry Association. I know the Washington solar industry really well, and we've put out a number of different RFPs that lacked, I think, in more engineering detail because our assumption was that the industry would really want to have some kind of ownership of the design and engineering of these projects, kind of value engineering. And that was a bump and scrape that we took. We heard pretty overwhelming feedback from the industry that they wanted to see, more due diligence done on the front end so they could get in and get out. And so, I think for us, like not having hubris, but really recognizing this is still a new industry. And, the Big Beautiful Bill made it really clear in my mind that everyone is turning their gaze towards microgrids and energy storage. And so we we really do have to think about how are we developing these projects that are supportive of the installers who will be building them and constructing them, while being representative of the industry. And unfortunately, in our experience, it's a balancing act that we have to throttle that kind of line to really get it right. What we found is 30% kind of conceptual design is great for the RFP, and then having a strong partner like Mayfield to work with the selected contractor to get it through that 100% after the contractor's selected is the best way to prevent changes on equipment down the line. But again, every project's different and unique.
Mm-hmm. Eric, yeah,
Yeah, I can hop
hear
in
your
here.
top. Yeah, no, I want to hear your thoughts on it.
I'll second that. I mean, I can just provide some examples of, or like second projects that I've been on that, on the early stage up to the 30% design, we don't have the proper equipment selected. And then you move into the RFP, you do the RFP, and you kind of, all of a sudden you're in the permitting phase, and you should be going full steam ahead towards permit drawings and towards construction. But actually you're going back to square one to reassess what the equipment should be, and to actually reassess the equipment, and even looking at the project goals and be like, hey, we need to be able to island the microgrid and have the generator charge the battery while allowing a black start, and closed transition so that the facility doesn't lose power. And then, if the equipment has not been selected early on that can do that, then essentially you just have to start back at square one with the design. So I'll just underline the importance of that, of what you were saying, Markus.
Yeah, absolutely. It's and finding that, yeah, getting that design as close as possible, and obviously 30%, it's not, finalized. There's a lot that can go change there, but having a good solid foundation is super important and makes for a quality project that you can see through into construction and commissioning. So getting into that, delivering an operational ready microgrid is an important thing. And one of the things that I'm going to pick out of this kind of list here is that programming, the third bullet there. I mean, we probably could spend a lot of time talking about every single one of these boxes, but for us, the microgrid programming is, unfortunately, one of my favorite sayings is ready, shoot, aim. And that is definitely what we have seen when it comes to the programming aspect of it. So highly got to get that early. You need to understand who's doing it, who's doing the programming, what is it accomplishing, how are you doing it? It's not enough to just say, here's an SEL relay, or here's, the protective relay. Have fun. So for me, that's a big one that I've seen, and I'm just kind of curious on your guys' side. I'm presuming you've seen similar things, but just kind of where those hurdles are for you as well. Eric, I'll have you. Why don't we start? Throw it over to you.
Yeah, definitely. So finding, having getting the getting a contractor that is familiar with the various industry leading equipment, and who's actually and if they're not, that's fine, but actually who's comfortable getting up to speed and really diving into the weeds of this is how this specific system works and how it's programmed, because all these different manufacturers, they have different protocols for how they communicate with each other and different things that they are capable of doing, and it's very nuanced, and I've been on multiple commissioning commissioning supervision things where sometimes it's not totally clear what the programming has been done, and that the system is capable of doing what the project goals are, but maybe it's not configured perfectly to do so, right? Something as specific as what's the state of the charge of the batteries when I switch over from from powering the batteries to the generator, and just getting that sequence of operations correctly programmed, and also communicating in a way that's visible to everybody, whoever the system operator is, and that it's very clear this is how it's going to be maintained and operated in the future. That's just one of the large challenges that I see.
Sure.
I think that's so bang on, Eric. And I think, documentation especially is really important. We know that maintenance folks at facilities change over time, and making sure that we've clearly, marked everything on the site and articulated what the kind of dispatch analyses are and programming kind of profiles. The way we like to kind of reference this and frame this at Cascadia is, these projects, what's beautiful about a microgrid and energy storage is you can provide value in front of and behind the meter, regardless of where that energy storage system is interconnected. And so we think about, supporting the grid, providing grid services as kind of a means to support grid operations. That's power reliability. And then backup power is resilience. That's how we're responding to a grid event. And you'll need to run multiple different dispatch analyses and optimizations to optimize the system and the relay profiles for each of those different kind of subsections. So there's a great amount of energy analysis and kind of programming that you need to do if you're going to have those dual benefits, which you really want to in order to optimize the economic kind of viability of the project as well as the resilience capacity of the project. So it's really, really critical to get this part right and to recognize that you might not, and you should be coming back until it is right. Keep eyes on that thing.
Yeah, for sure. I like that. And keep your eyes on it until it gets right. That's definitely an important thing. There's actually, you guys are kind of hitting some common threads, and I want to kind of when we wrap this slide up, there's some things I definitely want to bring in. And I see there's some questions that came in around the procurement stuff. So I'm going to wrap those back into this as well. So O&M side, this is one where I think the industry as a whole probably, again, I would say the microgrid industry still very young, we're very much learning, but I think this is one where we're probably lacking and planning around this. And so definitely want to talk about that and kind of some of the strategies around that after we talk about the final kind of end of life here. But one of the things too that I wanted to talk about, and Markus, when we were doing the planning for this, had a very interesting call yesterday that you weren't on, but I could have sworn from your comment that you were actually on that call with me, and really getting around the O&M side of it and reevaluating the system really, and understanding we're now 3 years in. Yes, it's important to do your O&M, battery health, disconnects, all the things, all the safety things for sure. But part of that O&M also needs to be analyzing the system. The grid services that we programmed this for 3 years ago, do they still apply? Do those rates still apply? Are the rates different? Has the load profile changed on the building? So this is not something that we just get to, it's not a PV array where you put it on the building, it's going to pump out kilowatt hours and you get what you get and we're all happy about it. So I think that's one of the big things and this is something that actually, because of that call around our education summit, that was exactly what it was. And so looking at a previous microgrid and talking with the facilities manager, and he's asking questions, and it's like, okay, we need to be doing this. So I guess, how are you guys approaching that, Markus? Just, in terms of that's 3, 5, 10 years down the line, it's kind of hard to get people to get excited about paying for something like that, but it's something that needs to be planned for.
Well, if we do that dispatch correctly, they should have the financial resources to pay for kind of multi-year O&M support of their project, right? I think it's important to recognize we're living in an age now of really transformative load growth. And that load growth is happening both behind the meter, inside of our microgrid, as well as outside of it, right? And that will impact how we optimize and dispatch these assets. So recognizing, like you said, Brian, the human aspect of load is really critical, as well as the financial implications of load in the distribution system. I very much believe that the distribution system is the dance. That's the point, right? Like, we are delivering power where it's being consumed, and we can do that really effectively and really efficiently, but it takes some vigilance. And I know that on average, the solar industry, it takes about a week to 2 weeks to respond to a failed inverter or MLPE or module. That's not good enough, right? If we're building energy as infrastructure, we need to be a 3 to 4 hour response time to an issue. And so that will require a different attitude from the installer community than we've traditionally had, and a different structure of their businesses, to be able to respond to these kind of any issues that might occur in a timely way. So I just want to really underscore that if you're an installer that's interested in supporting microgrids and building these systems, really, really think about what that means, because these could be life-giving and life-saving pieces of electrical infrastructure that we're building.
Yeah, and I'll add on top of that. I think this is what you were mentioning, Ryan. But yeah, the importance of having a regular cadence of just like checking in on this is how the microgrid is operating, and from a programming perspective, looking at what the rates of electricity, if we're grid connected, for example, what the rate of electricity is, and if that rate has changed, if the structure has changed. I mean, ultimately, the client or the microgrid, it's sitting on a dispatchable asset, and the conditions of the grid change year over year over year. And if you don't update it, like it'll still work and probably still meet the project goals, especially if it's resilient. But if there's an economic factor in that as well, not doing that is leaving significant cash flow on the table for the project, right? A small change of the utility rate, just maybe by an hour or two, if you take the time to update the programming, could be like 10, 20, it could be thousands of dollars of project revenue that could be realized just by having a cadence of updating that year over year. So yeah, just.
Yep. Absolutely. And I think even, understanding that and looking at sometimes even seasonal, spring versus summer versus winter, like the benefit, where we're at, we in Oregon, maybe in Western Oregon, we're not going to have the greatest solar resource in the middle of winter. So we might want to save that battery a little bit more for its design resilience use. Whereas in the summer, hey, let's go for it. And you can utilize that battery. We can dispatch it a little bit more. So I think that's even seasonally, but that gets very hands-on and very making sure that things are getting changed and looked at on a regular basis. Okay, end of life, and then we'll get to move on to the next slide. Just kind of, for us, end of life is something that we need to be looking at. Codes and standards tell us you need to be ready for this. You need to make a plan for this. You have to have it, as part of codes that we're under right now. A decommissioning plan is part of this. And, today I can't tell you where to recycle this stuff, but we need to be making a plan. We need to be thinking about that. So I think this gets all into that, kind of rolls all the way back to the planning side of it, is engaging with the community. How are you going to deal with this when this thing does come to end of life, and utilize the equipment or not, or how are we going to dispose of it properly? And then potentially recommissioning it, bringing in new stuff. And of course, that's a hard one. It's like, that's the crystal ball, right? What are we going to have for equipment in 15, 20 years in order to recommission something like this? So I think it's just a big one to consider. And I don't know if you guys have a lot of thoughts that you put into this on for your own systems.
So on all of our feasibility studies, we'll do a degradation analysis on the project. And part of that is just setting kind of expectations with the client of, what does daily cycling of this BESS look like as far as degradation after 10 years, after 15 years, after 20 years? And when is it necessary to replace the equipment? And what does that cost, right? And it's really critical in our mind, since we're working with so many vulnerable and low-income communities, like having an answer to them when they ask, well, what's it going to cost for us to decommission and dispose of this system is really important, and being able to hold up your hand and say, I don't know exactly, but this is our best estimate, and let's keep thinking about that and talking about that over time and preparing for it, and maybe holding some of the savings of the system in an escrow so that we can afford to effectively dispose of it is going to be really important for them, so that they're not burdened with this shock in 25 years. But realistically, these energy storage systems can last a long time if they're well maintained.
Mm-hmm.
And so how we dispatch them and how we optimize them impacts end of life just as much.
Absolutely.
Yeah.
So one of the questions that came in, so there's a bunch of good questions that came in. I want to also keep us rolling because we have a few more things to talk about. But I guess, and this is always the million-dollar question to me. Max asked this, about valuing the benefits, economic and otherwise, to microgrid resilience. And Eric, in your example that I promise we'll get to, there is some, it was a cold storage facility. There's some very, the dispatch on that, on the battery, and the kilowatt hours and the peak demand and all that kind of stuff. That's a real, it's more of a straightforward, here's the dollars and cents around that. When it comes to a resilience, and maybe even around the resilience on that specific project, just because your cold storage facility goes down, you lose inventory, that equals dollars, right? But when you're talking about a community center and you're talking about an emergency center or something like that, that's always been the one. And I don't know if you guys have had cracked that code in terms of how to value that, but I think that it's one it's an ongoing question and one that is not easy to answer. So I know that's not really a question, but I guess Eric, how are you when you're talking with people, valuing resilience?
I mean, if there is an economic use of a facility, then yeah, I think like you were alluding to, Ryan, it becomes a little bit more straightforward, right? If this is a manufacturing facility or there is a direct cost for a downtime. So that's kind of actually an easy one to handle. The harder one is when it's a community and they either don't have power, like let's say they don't have power beforehand, and then they get power with this microgrid. How do you put an economic value on not having power for a couple hours, right? It's really hard, and I don't have a really good solution to it. Markus, if you have any rules of thumb, I'll pass it over to you.
This question has been keeping me up the last 2 years. I'm obsessed with this question. So we don't have the time today to dive into it. I think value of lost load is really interesting. I think look at what Clean Coalition is doing in California with their resilient energy subscription concept. It's fascinating. I think it's close. And I'll shamelessly plug in Washington. We've got a summit in October where we're going to be diving into this for an hour long. How do we value resilience and should it be represented in utility rate structures or energy markets? Really, really, really interesting question.
And I think that summit's the week after ours, right? So come up to Seattle and stay for a long time. Just stay. It'll be a gorgeous time of year. It's the best time to come up, in my opinion. So, okay, I'm gonna keep us moving along. There are lots of great questions, but I do want to make sure that we hit on some of these things because we've talked about these. So roles and responsibilities. Markus, I want to just kind of throw this over to you right away. And this was, I think, kind of when we were talking about this, you were talking about a lot of this. And so construction, we get to see it. It's big and shiny. We get that win, right? There's things in the ground. We get to look at it. That's all great. But it's the things that are below the water. It's that setup that makes it really important. So I guess just, talk about this a little bit, and then, we're going to talk about development hurdles a little bit and kind of the three-legged stool there coming up next. But on this, just kind of what are your big takeaways on this?
Yeah, I think this has been a through line of this conversation we've had today so far. But I think the bottom line is there is so much that you need to do on the front end to ensure a successful project. And it's oftentimes, it's hard to see. That kind of social, economic, technical work is hard to see on the front end, but setting up the project for success is really critical. I like to say that we can do hard things together when we support one another. So having really excellent engineering partners like Mayfield, having really excellent EPCs, having really excellent engagement with the utility to understand interconnections and controls, and the fire marshal to understand safety and reliability. Like, it's critical. It's critical that you're taking these projects seriously and taking the time on the front end to really well optimize them and educate both the community, the stakeholders, and the installers on the goals of the project. And if you do that effectively, then what you get is this beautiful construction project that's going to operate for decades in service of the community. But if you skip any of those steps, is the Titanic, is that too rude to say? It's just, you don't want to skip those steps because there's a big effort.
Well, and I think any one of these steps can be a major hurdle and a major roadblock, could potentially even kill your project if you don't, we've seen it on all of these. Just there's some of them maybe seem obvious. Financing, of course, you have to have the financing, but the fire safety, going through, and if you haven't talked to your fire officials and they have a certain mindset or something around energy storage, then that could be a major thing for you to have to get past. And so, yeah, all of these are definitely, part of, and it's again, part of the whole conversation that we've been having today around just kind of the hurdles and then kind of what those responsibilities are. Eric, I guess while we're here, before we jump away on this one, what would you add on these roles and responsibilities?
Honestly, I think Markus said it beautifully, and I'll leave time for the next slides.
Okay.
Yeah, nothing more to add on this one.
Well, let's jump right into that then. So, and we do have a couple of case studies that each of you are involved with. So I want to make sure that we give you guys plenty of kind of airtime for that, if you will, to talk through those and taking all of these lessons learned and putting them into practice. So this one, the three-legged stool kind of concept here, social, technical, and economic. Markus, I think that you're really got your finger on the pulse on the social side. I feel like the projects you're working on, you're very engaged with the communities and things like that. So I guess talk a little bit more about that, the social side, and how that comes into play on the development.
Yeah, I think we've learned so much from our work in Washington with the Washington Department of Emergency Management inside of Commerce. They've really helped to kind of help us to see and understand how emergency management is actually deployed in communities in an emergency, in a resilience scenario, and recognizing, that your load profile in a typical outage is going to be very different in an emergency. So, you can do your 30-day load study, you should, but you should, in that 30-day load study, you should be trying to simulate an emergency scenario. If it's a mass care facility, if it's a communications hub, whatever the use case is, and recognizing that, again, we're living in a dynamic time when it comes to electricity usage, and that social element and how the project is supported and operated in an emergency is going to be critical to informing how you do your technical and economic analysis. So we've always found the best thing is to start with this kind of social engagement with the stakeholders at the site and with the community as a lens through which we then investigate the technical and economic components of a project. I'd pass it off to Eric. I'd love to hear your thoughts on, the social, technical, and economic side of this tool.
Yeah, definitely. Yeah, I mean, and yeah, let's say like after it comes from the social side, the technical, economic side, specifically technical. We've touched on this a couple times, but the faster you can get somebody involved that knows what is possible, that knows what the equipment can do, that knows how are we going to hit the project goals or the needs of the community, the better off the microgrid is going to be, right? I think in that first column that we were looking at of like, this is the feasibility study, looking at the technical, like, this is what we can do. And then from there going, okay, how do we make this work financially? And that often could be doing an economic, like a financial cash flow model. It could, lots of tools out there to do it. There's some home-baked ones. A lot of developers have home-baked ones, or, like Zendy is one, or Homer is one. You could really just, even, some publicly available ones from NREL, like the MDT. There's some good options there for putting together a quick financial model and be like, oh, hey, this microgrid, it has legs, and we can go forward and like look for financing for it. So, without one of these legs of the stool, like the community's there or the technical's there, but there's no funding or the grant's going to fall through, the stool falls over, right? Or the microgrid doesn't make sense from a technical perspective. We can't interconnect. The utility is going to shut it down. Falls over.
Yeah, and I would say, at the risk of beating the drum too much, just this all, to me, it all goes back to feasibility, because of all three of these are going to come, in my mind, in a feasibility study. Technically, we can build whatever we want, right? I mean, technically, almost anything's possible if you have enough money and you have the willpower to do it. So it's not always just, can we do it, but does it technically make sense? But then, of course, the economics need to play into that, and how do those two interplay? And then the social aspect, if it's not going to be accepted, then it's just not, it's not going to go anywhere. So And part of the feasibility studies should be incorporating all three of these in order to present it to or incorporating technical and economics specifically to present to the communities and present to whoever it is that's owning this to, get that social aspect. So for me, it's very much circular, very much all engaging. All right. So actually, I saw a couple of questions. See if we can do them quick. And also, I want to make sure. So there was actually a previous question or previous slide. I missed this on this about the programming. So we asked about programming refer to an actual code microgrid uses to manage events, or is it a broader term? And specifically on that one, in that slide we talked about controls programming. And so in my mind, that's very much how is the microgrid getting controlled very often with relation to the utility. But it can be much bigger, much broader. We do have companies that are doing load management, and we're going to start seeing that with as new products come out and able to be dynamically managing loads. And so there's some programming associated with that. So I would say it is kind of a bigger picture, but I think in the sense of controls programming in my mind, and you guys can disagree with me if you want, but it's a lot about how are we interacting with the grid, how are we making sure that the utility feels comfortable that when they go out we are disconnecting, and we have this big battery bank and we're still going to power the loads, but their grid is going to be isolated from that. So for me, that's a big part of it. Okay, I do want to, and I see some other questions. I can roll those back in if we have time, but I want to make sure that we give time for both of you to kind of talk about these case studies. And this first one is a resilience hub. This is something that we're working with Markus on. But Markus, this is your project. I'd love for you to tee it up and kind of give us, the big picture, and then kind of what some of those key hurdles were that you guys encountered.
Yeah, thanks. So this project is really interesting, in that it was we were working with folks at Workus Island around looking at their comprehensive emergency management plan and how can we best support their community in emergency. And this is a great example of a facility that you wouldn't first think of. This is their performing arts center on Orcas Island. It's also their community hub, and it was defined as their emergency support function 6 facility. So their mass care facility during COVID. It's where they did all of their vaccinations. They passed out masks, and it's where the joint command center existed for the fire department, the police station, the Coast Guard, et cetera. So it's an island, literally an island microgrid in Orcas Island in the Puget Sound. It consists of about 134 kilowatts of PV/DC, both ground and roof mounted. The BESS ended up is a 500 kW BESS that we derated to 199 kW to stay within the Bonneville Power Administration's interconnection limits. And it's got about a 1376 kilowatt hour capacity on the BESS. There's also a 150 kilowatt generator that went in new, several EVSE, level 2 EVSE chargers, and then a new interconnection. So the point of common coupling and isolation transformer, you can see kind of in the front top and middle, all went in kind of line side of their existing 3-phase equipment. So there was a lot of kind of electrical restructuring in order to interconnect this system, and a lot of engagement with Opalco, the serving utility, who was really excited and supportive of the project, as well as, obviously the site host. There were a handful of hurdles with this project. We did a really robust geotech analysis with an excellent local geotech contractor. Then we got out there to install the ground screws and had refusal on all of them. So we ended up pivoting and digging and pouring concrete on that one. Obviously the BPA interconnection was an issue, and then just understanding kind of how the facility would be changed in its usage. The load profile in an emergency is very vastly different than the load profile under normal operations. So there's a pretty significant difference in how the system's operating when the grid's up to how it will operate when the grid's down. And so balancing that was pretty tricky on this one.
And so on this one, again, this is something that we are working with you on, and so it feels like, I guess, sounds like some of the hurdles. The utility itself, that's one that that's a small kind of a co-op type facility or utility. So for me, that's been one of the ones, just working in different jurisdictions, working with different utilities. And so I think just being able to work with them and understand and help educate them on what this is, what it isn't. I think one of the things that I've seen on this is not this one specifically, but other utilities, they've known generators. I mean, we've basically been doing microgrids with generators, right, for a long time in some very real senses. And they know automatic transfer switches and they feel comfortable around those. And so working with them, I think that's one of the technical sides, is just, I guess, for the audience, just understanding doing those grid isolations, and sometimes it takes time and effort to do that. And Eric, I know you're nodding because we have a project where we're kind of coming up against that ourselves. And so for me, that's always a big hurdle. Not necessarily in this specific project, but that was just one that I thought of as you were talking about that, and I heard the small utility.
Markus, were there any specific hurdles with the community or things that were not foreseen, or kind of things that you learned during the community like site discovery phase that surprised you?
Well, the first thing that we learned that was really exciting, Eric, was that this would be the first node of a community multi-node microgrid that they're hoping to build in East Sound. So that's really exciting and changed how we thought about the system dispatch and kind of sizing, and that we suddenly realized, oh, this project may support more than just this facility in the future. So this is all behind the meter single node, but can be networked into a multi-node microgrid in the future. And so that,
Nice.
That's an exciting prospect, and one I hope that will continue to catch on that trend.
Super cool. I'm curious to hear more about that, but maybe that's later.
Come to Seattle and we'll talk about it some more.
Nice.
All right, let's jump into yours, Eric. Let's see, just keep an eye on the clock, get close to the top of the hour. So another microgrid system, a little bit different angle. So I guess, kind of tee this one up for us, and what the project was, and kind of what the goals of the project and how you met those.
Yeah, definitely. So this is a purely, the goal of the project was kind of purely economics. This is basically started with a blank plot of land in Madera near Fresno, California. So basically like around 300 square foot plot of land, and as an investment opportunity to the firm Arrigo Investments. And what they were looking at doing was doing a cold storage facility on this plot of land, which is essentially somewhere for farmers to store crops that are harvested at one point, but they want to sell it later on in the year. So specifically, almonds are a huge crop in California that it's harvested for 3 months of the year, like the entire amount supply of almonds, but it's sold throughout the entire year. And California provides the almonds for it's just a huge part of the industry. They went to do a utility interconnection study, and the timeline for that was 4 or 5 years, right? So essentially just makes the investment in the project non-feasible. So the way that they address that, or the way that we addressed it, is to do a microgrid. Essentially look at the microgrid as an option. It's like, hey, what combination of technologies would allow us to disconnect from the utility grid and get this built within 12 to 18 months timeline? Do the math on that, do a feasibility study, figure out the goals essentially economics, and it makes sense to do a microgrid on the site. So ultimately, what allowed this project to go forward was to do a microgrid made up of its 1.2 megawatts of solar, 2.4 megawatt hours of batteries with 1.2 megawatt inverter capacity on that, 2 1.2 megawatt natural gas generators, kind of to provide backup to the solar and batteries, and then the average load around 200 and 250 kilowatt of average load throughout the day. So looking at an autonomy of approximately 18 hours or something, and the facility was developed and engineered by Scale. We were the owner's engineer on it, and then the investment was the Origo Investments. And it's a classic example of this project couldn't have been a project without a microgrid, and now it is a project with microgrid. And there's some pretty cool things that they are doing with the grid. one of the interesting ones to highlight that we alluded to earlier is just like the financing structure of it. A bunch of different financing structures are available, but one of the options here is to do energy as a service, where the operations and maintenance of the actual microgrid components can be done by the developer, and then the electricity is sold back to the actual cold storage facility. And this is one that we see, so it's been operating for about a year now, and you can see what the generation profile has been. We've got a mix of generator, solar, and batteries. And some of the results from the first year have allowed us to be like, okay, we need to make some changes, going into the next year, of like, need to like install a different controller, or, redispatch in a certain way, to actually like get more value from the solar and the batteries. Interesting statistic on this one is that downtime has been less than 0.5% for the year. So effectively allowing the successful operation of the cold storage facility.
Nice. So I guess I'm curious. So you mentioned, maybe you need to do some tweaks, reevaluation of that. Was that something that was pre-planned as part of the project? Like, we know that in a year we need to reevaluate this. So this kind of gets back to our previous conversation of that O&M and just kind of thinking about that. Was that something that the developer here was able to put on the books, I guess?
Yeah, exactly. And so yes, it's pre-planned, and part of the reason for that is that the way that the contract is set up in terms of like an incentive structure is like they're paid, a monthly fee, and they're also just like responsible for the operations of the plant and get benefits from actually like the electricity from it. So the incentives line up to like, if we make changes to this and can provide power at a higher availability, then they're compensated financially for that.
Okay. Great. And then there was one question, and you said the same word, so I want to bring it up because the question came up, and we were talking about it in the prep call. So we only have a couple minutes, so we can't dig too deep into it, but offering energy as a service. And so I guess I'm curious, the question is, does that offering energy as a service, classify the company as a provider, a utility provider under current regulations? One thing that I'll say about it is there was a recent microgrid bill here in Oregon. I know, Markus, you're well aware of that, and can speak, I'm sure, much more highly about it than I can. But I just would kind of throw it out there. That's going to probably be somewhat regional, somewhat local in terms of what that answer is. But I guess, Eric, since you talked about it, what was the 30 to 45-second answer on the energy as a service?
Yeah, sorry, I was finding the mute button. Yeah, I mean, on this, from like a legal perspective here, I would say no. They're not a utility. But right. Yeah, I think like you said, it's very, very dependent on location. And, I think, you got the over the fence rule, and, you essentially saying that you can provide power to yourself and maybe an adjacent property. But as soon as you start doing it to a larger community, then you start getting into the territory of needing to form a load serving entity, the utility load serving. Yeah. And, cool. In this case, very much wanted to continue to stay as a microgrid and not get into the territory of trying to form an LSC or a utility.
Sure. Markus, is there anything you want to throw on top of that one?
I would just say that the holy grail for our industry is aligning incentives between our technology and the utility industries. So I think it's important to be engaging with them. And if we can do things where they're benefiting from it and supporting it, we're going to see this grow even faster. And specifically in the Pacific Northwest, we're finally getting a day-ahead market. It's coming. And how that manifests in utility incentives and rate structures, could really benefit the expansion of microgrids. So watch that space and engage. It's going to be an exciting couple of years in the legislature.
Awesome. Okay, well, we're getting right to the top of the hour, so I'm going to put this out there. As I mentioned before, this is a conversation. This is a discussion we're going to have at our education summit. So highly encourage folks to take a look at that. Come join us up in Seattle in October. All three of us will be there, be able to continue these types of conversations. So take a look at that. Would love to see folks there. And then finally want to just put out, put our contact information here. So if you do have questions, comments, and, as always, just a ton of great questions in the chat. Can't get to them all. And we really appreciate if you want to continue the conversation, you can reach out to us here. So thank you, Eric. Thank you, Markus. This has been wonderful conversation. Thank you to everybody out in the audience. I really appreciate you taking the time.
Thank you, Ryan. Thank you, Markus.
Thank you, guys. Always fun.
Great. Thanks. Have a great day.
Talk to you.